People think stopping a car is easy. Push on the brake pedal and the car stops. But there's a lot more going on here. A moving car travels at approximately 1.5 feet per second times the speed at which the car is moving. If you're driving a car 10 miles an hour, then in 1 second you'll cover about 15 feet. At 20 miles an hour, you'll go 30 feet in a second. At 30, you'll go 45 feet in a second. Remember that we said approximately 1.5 feet per second. At 30 miles an hour, you'll actually go closer to 44 feet in a second, but we're trying to keep the math simple here. This same thing works for fractions of a second too. If at 30 miles an hour you're going 44 feet in a second, then you'll go 22 feet in half a second, and you'll go 33 feet in 3/4 of a second. And that number, 3/4 of a second, is a real issue here. The total stopping distance of any car has 3 parts. The perception time, when you realize you need to stop, the reaction time, when you do something about making the car stop, and the braking distance, which is the time it takes for the car to come to a stop after the brakes are applied. Now, let's assume that you're driving along at a nice, safe 30 miles an hour. Here's our road. From the looks of the scenery, I'm guessing it's somewhere north of Lubbock. This red car is the one that's just in front of you on the road. And this green car is you. Oh, come on, we can get a better car than that. There you go. Anyway, both of these cars are cruising along at 30 miles an hour. Then suddenly his brake lights come on. He's stopping. You have to notice the brake lights and recognize what they mean. The time it takes you to do this is your perception time. And perception time takes the average driver about 3/4 of a second. 3/4 of a second to see the reason to stop, realize what it means, and decide what to do about it. Remember, though, that your car is still going 30 miles an hour at this point, and during that 3/4 of a second, your car is going to move 33 feet forward. You're going to get 33 feet closer to where he was when he put his brakes on. You should also remember that we said it took the average driver about 3/4 of a second to perceive of the reason to stop. If for any reason you're not paying attention, it will take you more time to see the need to stop, and during that time your car will get even closer to that other car. After you perceive of the need to stop and decide what to do comes the reaction time, when you actually do something to stop the car. You take your foot off of the gas pedal and put it on the brake pedal and push. The reaction time, the time it takes to get off the gas and put on the brakes, also takes the average driver 3/4 of a second. And during that time, the brakes aren't actually applied yet, so you're still going 30 miles an hour, and you're going to get 33 feet closer to that other car. So 1.5 seconds have gone by before you've applied your brakes. The red car has had his brakes on and been slowing down for all that time. He has a 1.5 second head start on you, and meanwhile you've moved 66 feet closer to where he was when he applied his brakes. So let's talk about how much time and distance will get used up before your car comes to a stop. This is the braking distance we mentioned earlier, the third part of total stopping distance. We've been talking about physics in this chapter, so it shouldn't be a surprise when we tell you that there are a lot of variables that affect how fast your brakes will stop your car. Your braking distance can be affected by the weight and size of your vehicle, by how good your brakes are and what condition your tires are in, by the surface of the road, by the weather conditions, and by too many things to list here really. Under normal conditions, a car decelerates at 15 feet per second. If you apply the brakes at 30 miles an hour, which is 44 feet per second, remember, then after 1 second, you'll be going 15 feet per second less, which is 29 feet per second, or almost 20 miles an hour. After another second, your car will be going 15 feet per second less than that. So 2 seconds after you put on the brakes, you'll still be moving 14 feet per second, or about 9 miles an hour. It will take almost another full second to get your number of feet per second down to 0. In other words, to stop the car. At 30 miles an hour, it will take almost 3 full seconds between applying the brakes and stopping the car. And during that 3 seconds, your car will move forward approximately 45 feet, about 15 feet per second for 3 seconds. Now add in your perception time and reaction time. It takes you a total of approximately 4.5 seconds from the time you saw his brake lights to the moment your car stops. And during that 4.5 seconds, your car moved approximately 110 feet farther down the road. Most accidents are caused by some overconfident person not being careful enough because they thought they could handle any situation. Keeping a safe following distance may seem nerdy, but overconfidence and carelessness can get you or somebody else killed.